In the last video, we talked about the hashing. We learned about the concept of hashing, what are the hash functions, how do we calculate the hash values, and how do we use the hash values to find the index to basically enable faster lookups. In this video, we will see how does it all relate to Java. Where and how do we use hashing as far as Java is concerned. So there are many use cases of hashing, like we use hashing in security and cryptography. But in general, we use hashing with hash-based collections like HashMap and HashSet. Okay, what happens with these collections that we pass an object, we pass an entity to the collection, then based on that entity, it calculates a hash value. And that hash value is used to find an index, a location for that entity. And at that index, that entity will be stored. The problem with Java is, if you think about it, there could be n number of classes. There are thousands of classes in JDK itself. Then we can create our own custom classes. So how do we create a kind of universal hash function that can return the hash value or the corresponding hash value for any object that we pass it to? To solve this problem, what Java does, in the object class, there is a method called hashcode method. So as you can see on the screen, this is a native method. With the help of hashcode, what Java says that as long as your object or your class is overriding the hashcode method, and if you are passing the object of that class to any hash-based collection, for example, or any hashing utility that is dependent on the hashing, then what it will do, irrespective of the type of class or object, it will simply call the hashcode method, and that hashcode, depending on the implementation, will return an integer value that will be used as the hashcode of the object. So that is the basic approach of calculating the hashcode for any object using hashcode method. If we don't override the hashcode, the runtime will trigger the default implementation and it will return the hashcode, but it is recommended to override hashcode n equals at the same time for any class that we are creating from scratch, especially if we intend to use that class with a hash-based collection like HashMap. When we are overriding the hashcode method in our class, then there are certain things that we need to remember and that we need to make sure that we do it right. Okay, so the first thing is, and that is part of the hashcode contract, that two equal objects must return the same hashcode value. So it is mentioned here, if two objects are equal according to their equals method, then calling the hashcode method on each of the two objects must produce the same integer result. So if two objects are logically equal, then they must return the same hashcode, and that's why it is said and it is recommended that we override both the methods at the same time. So if we are overriding equals, then make sure that we also override hashcode. Second thing is, it is recommended to use the same fields in both the methods. So for example, here we have this student class, and this student class has two attributes, ID and name. So to follow the contract, what we will do, if we are overriding equals method and if we are using ID and name both in equals method to check the equality, then we should use both the fields in the hashcode as well. Okay, so for example, in the equals method, I used ID and name both, but in the hashcode method, I only used name attribute but left ID. Then it will break the contract. That could give unexpected results. Okay, so it is recommended to always override equals and hashcode together at the same time. We said that if two objects are equal according to their equals method, then they must return the same hashcode, but opposite is not true. If two objects are not equal, then it's not a condition that they must return unequal or distinct hash codes. If two objects are not equal, even then they can return the same hash code. But if they are same, they must return the same hash code. That is the condition. The third point that we need to remember is, for a single execution, when we ran the program for a single execution for the same object, if we are calling the hashcode method, then it must return the same integer. But if we run the same program again, it will be another JVM execution. In that case, it can return a different integer, but for the same execution, for the same object, the hashcode method must always return the same integer. Another important property of any hash function or hashcode method is that it must return random values to avoid hash collisions. Okay, so let's move on and try to override the hash code for the class that we created, student, and let's see how does it work. So we said that if we don't override the hashcode method, even then we can access the hashcode. So let's try that. Here we have a student class, and this student class does not override equals or hashcode, but we can still use the hashcode method and we will see how do we get the result back. So let's try to print the hashcode of this object. So we see a long value, basically a numeric value. And if we go to the object class, we see the return type is int. So it is an integer value. Okay, now let's try to override equals and hash code. How do we do that? It's simple. Most of the time it is recommended to use IDE to generate hash code and equals, because they use certain algorithm that we don't have to re-implement, and they are generally faster and more than sufficient. Okay, so let's generate the hash code and equals and hash code, and we will use the Java template. Here we give the fields that we are interested in for the equals method, if you see. So we said that we are going to use ID and name for the equals. Now here it is asking what fields do you want to include in the hash code. Now the thing is, we need to make sure that we use the same set of fields as we discussed, that it is part of the contract. Otherwise, the result could be unexpected. Okay, so we use the same set of fields, ID and name, and non-null fields. Okay, and then we create the equals and hashcode method. So here we see we are using ID and name, both of the fields in the equals, and similarly we are using ID and name to generate the hash code. In the hashcode method, we see that it is using hash method of the objects class, which is a utility class, and it is passing ID and name. What it does, if we go to the implementation of hash, it basically calls another method from the arrays class, which is again a utility class, and it is passing the var arg, which is multiple values. And if we go to the hashcode method of the arrays class, we see that for each of the element, it is basically calculating the hash code with this formula, where we initialize the result, then we multiply this with a prime number 31, and then we call the hash code method on that element. So whatever value we get, default value we get, we add that value to this result, and for another element we again multiply the result with 31 and add the hash code value. So that is the formula that is being used to calculate the hash code. Going back, now that we have equals and hashcode methods in the class, let's run the same program again to calculate the hash code, and this time this hash code will be generated based on this implementation. So we see a different hash code, which is valid because when we run a Java program, it starts the JVM, which is a fresh execution, and in each execution the value may differ. Before we wrap up the video, there is one more thing that I wanted to discuss, which is how do we find the index from the hash code. If you notice, the result of the hashcode method is a huge integer value which changes based on the execution. So it could be anything, it will be an integer value, but it could be anything. So how do we make sure that we always find the right index? Because we generally don't have an array that huge. The basic idea to make sure that we always find the right index is to use modulus operator, which is basically this. What modular operator does, if we perform the modulus operation and if we do something like a modulus m, then the property of the modulus operator is that the return value will always lie between 0 to m minus 1. So this is kind of an upper bound. So if we perform the modulus operation on this hash code, let's say the size of the array is 10. So if we do this, then it will make sure that the result of this modulus operation is always between 0 to 9. And that's how we find the right index. What we do, whatever value we are getting from the hash code, we perform a modulus operation using the size of the array, which could be anything, and it will always make sure that the corresponding value, the result will always lie between 0 to size minus 1, and that will be the index in the array. All right. We will see how does it work in the next video when we discuss the implementation or the inner working of HashMap.